It is so great to be with you all here. And I'm here to talk about this terrific book, Space Ethics, to have us all talk about it with Dr. Brian Patrick Green, the author of this book and our colleague at the Ethics Center of many years. Dr. Green is the Director of Technology Ethics at the Ethics Center. His work has focused over the years on the ethics of technology, including topics such as AI and ethics, the ethics of space exploration and use, the ethics of the technological manipulation of humans, the ethics of mitigation and adaptation toward risky emerging technologies, and various aspects of the impact of technology and engineering on human life and society, including the relationship between technology and religion. Brian teaches AI ethics at Santa Clara's Graduate School of Engineering. His academic background includes doctoral and master's degrees in ethics and social theory from the Graduate Theological Union in Berkeley, and his undergraduate degree is in genetics from the University of California at Davis. So this book is a great achievement. Brian completed and published it this year, available from Rowman and Littlefield. You can find it on Amazon. We encourage you to go get it. It's a terrific book, and really in many ways an unprecedented one. Who's writing about space ethics now other than Brian? But there's all kinds of issues in space that we've got to deal with that are coming at us in all sorts of different ways. So we're entering an unprecedented era of space exploration, commercial and private sector space travel, missions to Mars, military space technology, among other things, are all growing at an incredible speed. The names are familiar. Elon Musk, Jeff Bezos, and others have made history by creating advances that make space vacation, who thought of that a little while ago, more plausible than ever. Throughout history, humans have explored new places and making good and bad ethical decisions along the way. As humanity proceeds to explore space, it's very important that we learn from the successes and not repeat the mistakes of the past as we apply those experiences to space. We look forward to sort of the wonders of space, but at the same time, remember the human impact of our space obsession and the effects it may have on our planet. Space is truly a frontier rich with ethical implications, and we are really so happy at the Ethics Center and delighted to feature Dr. Brian Patrick Green to talk about his work on space ethics. Brian.
David, thank you so much for that very kind introduction. I'm going to share my screen now. Today, I'll be talking about my book, Space Ethics. Let's see, there we go. And as David was just showing the copy of it, I'll be talking about what is space ethics, Earth ethics, and space ethics. I'll talk about 12 issues in space ethics that kind of reflect some of the chapters in my book, and then talk about tools for space ethics or ways of thinking about different problems in space, and then the conclusion. So what is space ethics? Space ethics is the branch of applied ethics that considers good action and character in the context of space and Earth as a planet in space. In other words, taking Earth and kind of contextualizing it in the space context in which we exist. What's the relationship between Earth ethics and space ethics? Space ethics has all the same problems as Earth ethics, but the problems are bigger, as you might imagine. So for example, if we think about space debris, we can think about a problem that's literally larger than the planet Earth. There are whizzing around the Earth right now hundreds of thousands, millions of pieces of debris that are all going at kilometer per second velocities. And they present a danger up there. So it's a problem literally bigger than the Earth. Another interesting thing about space ethics is that it also thinks about the largest scales of time and distance. And it raises really deep questions like, why is the universe the way it is? What is the purpose of humankind in the universe? Is the universe about something, as NASA scientist Mark Lupacella likes to ask? Or one of the ways I think about it is the universe doing something? Are life and intelligence about something? Should humans be doing something? And if the universe is doing something, then should humans help or oppose what the universe is doing, which I think is an important question for us to ask. These are philosophical questions, but they have kind of religious resonances to them a lot of the time. Every ethic has a purpose which it aims towards. It has good things that it's trying to achieve and then bad things that it's trying to avoid. Religion can be involved or not in these sorts of debates. So, for example, there's some secular utilitarians who want to fill the universe with happy humans. And the paper that's in the background on this slide is a paper called Astronomical Waste by Nick Bostrom, where he says we need to develop technology as quickly as possible to get as many happy humans in the universe as quickly as possible as we can. But we can still ask ourselves, should we be doing this? And if so, why? What's the justification for this? And should we actually do that? That's the fundamental ethical question. And so I like to think about ethics as being the path towards the future. These questions are important to ask because we have to think about where we are going and how we get there. And if we don't have a conception of where we want to get to, then we're going to just be wandering off through the countryside, right? And this is a picture of Half Dome and the trail up the back of Half Dome. And if it's a very narrow path, you don't want to wander off. You will end up in a bad place. So as we're thinking about the future, we should recognize that wandering towards the future is something that we should do with some intention to it, not necessarily wandering, but thinking about where we want to be and how to get there. So these are the 12 issues that I want to talk about. I'm going to talk about each one of these very briefly. Each one of these is a pretty big issue. And I talk about each one of these, like I said, is roughly a chapter in my book. And I'll just go through them. So the first kind of big issue in space ethics is just the acute risk of flying into space. And if you want to think about all of these in comparison to an Earth ethical issue, you can think about, guess what? Vehicles sometimes crash or explode or things like that. And we want to avoid that because life and health are valuable. These same problems can also happen in space. Space, however, involves energies in the form of speed and fuel that are much more intense than we generally find here on Earth. And acute risks, these sorts of things are quick harms. In other words, things that you have to plan or prevent ahead of time. You can mitigate them, you can reduce the risk of those dangers happening, or you can adapt towards them. So there's a certain amount of risk that cannot be reduced, in which case you need to prepare for that. If you can have something like a safe exit from a disaster, some sort of safety system that'll protect you if a disaster strikes. This is a picture from the Apollo 13 mission, where of course they had an explosion, an onboard explosion. It almost could have ended in complete disaster, but they managed to figure out how to fit a square peg into a round hole with a lot of help and everyone thinking about how to exactly put that together. They protected their air supply and made it back to Earth. So chronic risk is kind of the next question. It turns out space is really unhealthy. Of course, bad things can happen with our health here on Earth, and we should avoid those things. But in space, there are just many, many things that can go wrong. There's problems with microgravity, radiation, neurological problems, blood pressure problems, digestive problems, muscle and bone wasting, atmospheric issues, contamination, and contamination can be biological, chemical, or physical particles. One of the things they discovered in Apollo 11 was that after they got back into the lunar module after being out on the moon, they discovered that the dust on the moon is highly irritating to the human respiratory tract. And because basically it's little pieces of broken glass, which is kind of what you would expect from a landscape that's created by, blasting the moon over and over again with meteors. So there are all these sorts of things that can be quite surprising because they're very different from Earth. This is Mark Kelly and Scott Kelly. They're both astronauts, and they did actually an interesting, they're identical twins, and NASA did a study on them to see what happens if they kept one on Earth and put one in space for almost a year, and then compared how they were different from each other at the end of that. So third issue, space debris. Space debris, like I said, is becoming a bigger and bigger problem. On Earth, we have our own environmental problems down here. And of course, trash is a problem. However, if there's a big object on the freeway, like if someone loses a piece of furniture off the back of their truck or vehicle overturns in front of you and you crash into it, then obviously that can be really bad. And this happens in space, but to a much worse extent, because like I said, everything in space is whizzing around at miles per second in terms of velocity around the Earth, at least in low Earth orbit. The higher up you get, the slower things go. But of course, we're all orbiting the sun also. So there's all these sorts of things to worry about in terms of speed. There are derelict satellites, there are dumped rocket parts. And anytime these hit each other, they break into tiny pieces. So, and those tiny pieces then go on and hit other things. And there was a NASA scientist back in the 1970s who saw that this was going to be a problem looking forward. And by the way, that's just some context for space ethics. People have been thinking about these ethical issues in space for decades now. And there are quite a few people who are thinking about this. However, how much actually gets done? That's kind of the next question, right? We can have a lot of academics and other scientists and people researching these things, but actually solving the problem requires politics and it requires cooperation. So Donald Kessler was the name of the scientist who discovered this idea of a debris cascade, where if we reach a certain critical threshold, all those little pieces of debris start crashing into each other, exploding into more pieces, crashing into each other again, exploding into more pieces of debris. Pretty soon you're stuck on Earth and you can't get out because the entire planet is enshrouded in too many pieces of debris. And this is just an example from the Space Shuttle Challenger back on this 7th Space Shuttle mission. It crashed into a paint fleck, a tiny, tiny paint fleck that was just millimeters across or something smaller than a millimeter. And it hit the windshield going at, several miles per second. It did not go all the way through the windshield, thankfully, but it got close. It went through a lot of it. And so these sorts of things are real and definitely problems going forward. So military questions in space. Of course, there are reasons that humans have militaries. Different countries have militaries. It's so that we can try to deter or defend against war. Militaries, of course, need to be controlled. They also need to be directed towards good goals and not bad goals. Militaries also operate in space. We have spy satellites up there. We have anti-satellite weapons. Russia tested an anti-satellite weapon just near the end of last year, and it created a huge amount of space debris, which is another problem. Military testing of anti-satellite weapons is a huge producer and contributor to the space debris problem. The Outer Space Treaty bans weapons of mass destruction and permanent weapons platforms in space. And so far, it seems like the Outer Space Treaty has done a good job of preventing those bad things from happening in space. However, we don't necessarily know, right? There could be satellites up there that have weapons on them that we just don't know about. Of course, if you want to think back to the 1980s, United States President Ronald Reagan had this idea for a Star Wars defense system, he called it, where you could shoot down ballistic missiles from other countries. This is something that actually works now. To a limited extent, we only have a small number of these interceptors in certain places. But and of course, they're all ground-based because otherwise they would violate the Outer Space Treaty. But this is just an example of how things are going in space. So asteroids, of course, if you're on Earth, of course, a rock can fall on you, which is bad. Nobody wants that to happen. It can also happen in space. And asteroids, of course, can collide with the Earth. Impactors can range in size from very, very small to very, very, very large, so miles across. And of course, a big rock can ruin your day. This is just a picture of an asteroid out there. And you get kind of the idea of what an asteroid looks like. It's a pile of other rocks that have all gathered together thanks to gravity. And this is a picture from, I believe, 2014, when a meteor crossed the sky in Chelyabinsk in Russia, and it exploded with the equivalent of something like 100 kiloton explosion in the upper atmosphere. It caused quite a bit of broken glass in the city. It injured about 1,000 people. And that's just one example of what these things can do if they hit the Earth. And of course, there are much worse examples going all the way back to the dinosaurs, for example, who were their extinction at least correlates if it wasn't actually caused by a very large asteroid hitting the Earth. So astrobiology is kind of another area of interest. Is there life out there? We know that on Earth, life appeared, and over billions of years, it turned into complex life forms. Astrobiology is the study of the origin, extent, and future of life in the universe. Earth is the only place that we know about that has life on it, but there could be billions or trillions of other planets out there with life on them. We just don't know. We know there are a lot of other planets out there. And of course, one of the interesting things about this, which raises other deep questions, right? Which is that the origin of the universe was just hydrogen gas. But if you leave hydrogen gas laying around for 13.8 billion years, I should say there's a little bit of helium too. It wasn't just purely hydrogen, but you leave it laying around for 13.8 billion years, it turns into people, which is kind of strange, just a weird trend in the universe, but it has to bring these questions to our mind. We've found a lot of habitable exoplanets out there, potentially habitable ones. They're the right size, they're at the right distance from their stars to have liquid water, and the number is increasing all the time. We find more and more planets, and we also find more and more that are about the same size as the Earth. So one question out there is that if there is other life out there, then we need to be careful of it. And so there's this concept called planetary protection. These other forms of life in space, they could be dangerous, they could be endangered by Earth life. And in any case, if those life forms go back and forth in some way, they would contaminate scientific investigation. And so if we want to do good science in space, we need to make sure that we're not polluting the places that we are looking for life with life forms from Earth. So it works to prevent forward contamination, backwards contamination. At some point in the future, we're going to have to think about lateral contamination between different objects in space because humans are going back and forth. And hopefully, if we have the right precautions, we'll never be subject to something like Martian COVID, or we won't have to worry about going to Mars and discovering life on Mars, which is very exciting, only to realize that it was an Earth bacteria that we accidentally dropped there on a previous mission, which would be a really big oops. And of course, if you watch most science fiction movies that are set in space, you'll realize that they have horrible planetary protection policies. They're always contaminating everything. All right. And this is a picture of the Viking lander. The Viking lander, the entire Viking lander back in the 1970s was sterilized in a giant autoclave before they sent it out on its mission. So SETI is a search for extraterrestrial intelligence. If there is life out there, there could also be intelligence. And if you want to compare this to humans here on Earth, of course, we discovered other intelligent life forms on Earth. We discovered other people as we traveled around. And of course, there are some very intelligent animals also. This could happen in space. And so people have been looking for extraterrestrial intelligence, ETI, for a long time. We don't have any conclusive evidence yet, but there have been some suspicious things out there. So finding ETI would not only be momentous, but it would also be risky because they could be friendly, they could be dangerous. And we know these sorts of things, once again, from our experience here on Earth, which is that even if people found other intelligent life forms out there, other people, we know that we haven't always treated each other very well. In fact, there's a lot of evidence that we've had a very bad track record on that. So we need to think about this if perhaps we meet intelligence someday in space. And this is with the collapse of the Arecibo telescope in Puerto Rico last year, the biggest telescope in the world. And actually, this telescope in China exceeded the size of the Arecibo telescope when it was built. But right now, China has the largest radio telescope in the world, and they can do some pretty good science with that. All right, new players in space. So not only countries have been involved in space exploration, but also now corporations like SpaceX and Blue Origin. Article 6 of the Outer Space Treaty says that vessels and settlements in space are subject to the jurisdiction of their sending nations. However, Elon Musk has already mocked the Outer Space Treaty. If you read the fine print on the Starlink user license agreement, it says randomly tucked in that Mars is a free planet and is not subject to laws of Earth, which is kind of an interesting thing. Lots of folks have looked at that and said, okay, that's not an enforceable part of your user license agreement. However, this idea of mocking the Outer Space Treaty has a bit of a problem to it. And so Musk and Bezos, they're on their way to space regardless of public approval. And then the question is, well, should we let them go? Because, countries on Earth could decide, no, private space exploration is not how we're going to go. Should we actually try to stop them? And then you can, of course, have an argument why or why not. And this is a picture of the new giant rocket that SpaceX is building. And this photograph was taken just last year. Very much in the style of some of those old pictures of skyscrapers where they have the tiny workers putting together these giant objects. So settlement of space. Obviously, people need places to live. If humans are going to be in space, then we are also going to need places to live up there, whether it's a small habitat all the way up to a city-sized settlement supporting life off of Earth and eventually self-sustaining life. It can't be something that's dependent on the Earth. So there are lots of places to choose from just in the solar system, some being more challenging than others. And there's always problems of radiation. There's always problems of temperature. Is it too hot or too cold? And all these sorts of other things to think about. So settlement is, of course, a very kind of sticky issue. And what would these places look like? Well, they could look like a dome or a set of tunnels or tubes. And you'll need some light to grow food up there and things like that. So, of course, we have so many artist representations of what these things could look like. Big issue, terraforming. Lots of people have talked about, trying to terraform Mars, for example. And we know this is possible because we're managing to do this already on Earth accidentally through climate change. We're warming the climate of the Earth. And so very soon on Earth, we might be trying to intentionally engineer the climate of the Earth back to the way it was before. This could also happen in space. If we want to terraform planets and objects in space, Mars is a prime location. It has water on it. It has carbon dioxide. It's just frozen and waiting to be thawed out if we can warm up the planet. And this is an artist representation of what that might look like. You start with Mars up there, and eventually it starts looking more like Earth. Now, of course, if you talk to anybody who does planetary protection work, they'll say, oh, this is a disaster of planetary protection. And if you ask questions like, well, what if Mars has native life? Are we just going to come in there and replace it with a bunch of life from Earth? That's some kind of colonialism, right? That mentality there of just going to some other place and making it like the place you came from. We can definitely raise questions about that. And at the same time, we can also see that there are huge, potentially beneficial things associated with this. In terms of, for example, just giving humans a new place to live or extending Earth life to a new place. And then we get into really big questions of should we? This is really the first chapter in my book because it's the first thing you have to talk about. If you're going to go on to these other issues, you really need to ask, we have to decide what we're going to pay for. Should we do it? How are we going to pay for it? Why or why not? There are, of course, good reasons in favor of space exploration. The number one reason being science. We've learned so much just from doing science in space, just from having satellites looking back at the Earth, not even thinking about all the other satellites that we send out even beyond the edge of the solar system now. It's been a big driver of technological development. Solar panels being a prime example of that. Solar panels, very early on, they were expensive, and so they were used for satellites. And now they've become much less expensive, and we're using them to shift our energy, production here on Earth towards something that's a renewable resource. Also in favor is international relations, whether it's competition or cooperation. It could be, back in the space race, the race to get to the moon. There was definitely a competitive aspect to that, but shortly after that, it became much more about cooperation. And so the International Space Station right now is one of the places where, Russia and the rest of the world have to get along with each other. So the Russian astronauts there and astronauts from the United States and other countries get along on the space station. There are also resources out there that we could utilize for things either here on Earth or in further exploration in space. Then there are questions of purpose. For example, the purpose of exploring space gives us something good, a purpose or a goal or things that we can aim for. And ultimately, there's the survival of the human species and other species of life that come from the Earth. We know that eventually the Earth will become uninhabitable. And of course, there are lots of other risky, dangerous things happening to the Earth right now, either in terms of the dangers of nuclear weapons or in terms of pandemics or artificial intelligence, all sorts of dangers out there that we need to think about. Of course, there's the opposition to that, which is that this is risky. It's very expensive. And whenever we're thinking about spending money on space, of course, we're not spending it on something else. So there's an opportunity cost to those things. There's a political aspect to it in terms of what is going to be the relationship between not only nations here on Earth, but if we create a settlement out there in space, how will it relate to the Earth? Will it be oppositional, as Elon Musk seems to be already setting up, or is it going to be something more cooperative? We could discover dangerous things, whether it would be pathogens from other planets or dangerous extraterrestrial intelligences. Who knows whether they exist or not? And of course, some people say people shouldn't go into space because people just ruin things. And of course, we know that we have made mistakes in the past here on Earth. But I think that people ruin things argument is actually not a very strong one, because the only reason we can have any conception of something being right or wrong or being ruined or improved is because we have conceptions of ethics. And the only ethically capable creatures that we know about are human beings, because we're the ones making these decisions and having these discussions right now. By the way, if you have questions, please put them into the question and answer little box down there, and we'll be asking those questions soon. So start thinking about your questions and putting them into the box. And so when we're thinking about space, we can think about, this fantastic photo from Apollo 11, or actually this isn't Apollo 11, this is a later Apollo mission, because you can see the space rover there. And we can also think about places on Earth that really could use that money at the same time. This is a picture of the island of Ebi in the Marshall Islands, where I lived for 2 years as a Jesuit volunteer. And one end of the island was a burning dump, and people would go into the dump and look for things to see if there was anything useful there. So all the time that we are spending, or all the money that we're spending on something like Apollo missions, could be spent, of course, helping people here on Earth who need that right now. So this really is a trade-off that we have to think about. How much are we going to spend on things? How much attention will we be giving to different subjects and trying to solve these sorts of issues? So we do have this choice. If you're in the United States, then of course we have our Constitution, which is based on we the people, and many other countries in the world are like that, although of course not all of them. We can decide what an appropriate use is of public money. And we can even decide whether this is an appropriate use of private money. We can say billionaires aren't allowed to go exploring space on their own, in which case they might just leave and go to a different country, which is, of course, a problem that has to be considered. But we should think about, what should we do? Because that really is the question of ethics. Should we do this? Should we do something else? So in my book, I'm not going to go through all of these. I just went through and counted up how many different kind of ethical concepts and tools I talk about in the book. It's something around 70, depending on how you split the categories or lump the categories together. Maybe you can get it as low as 50, maybe as low as 100. But I try to get all these ethical concepts in there. And a lot of these are just general applied ethical concepts, which you can apply to lots of different questions. My background, of course, is technology ethics. I came at it from thinking about genetic manipulation of humans and those sorts of issues. But it turns out that if you have these applied ethical tools, you can move them, a lot of the time, onto new issues. And so I'm just going to look at a case really quickly. Of course, we can't go over it in too much detail, but just to give you an example of how one of these ethical tools can be applied to issues related to space. So once again, here's a wide variety of tools. These are just some of my favorite ones that I like talking about. And one in there, natural versus human-made disasters, is kind of an interesting category when it comes to space, because in space, we know that there are asteroids out there, so we know there's a risk presented by these. And of course, there was a movie that came out just last year called Don't Look Up, which made quite a bit of splash. if humans can divert an asteroid from hitting the Earth, then we can also intentionally divert an asteroid towards the Earth. This is case one up here. In this case, responsibility is very clear. If we divert the asteroid, people did that. Somebody, probably a relatively small group of people, decided to do that, whether it was one nation or one space agency or one military decided to direct that asteroid away from the Earth. That would be great. You could save a lot of pain and suffering here on Earth if you could divert an asteroid that was supposed to hit the Earth. Unfortunately, the opposite is also possible, which is that someone out there could look at space, an asteroid, and say, oh, that asteroid is going to be a near miss. What if we hit it and divert it towards the Earth instead? Then we can cause this huge disaster. What their motivation would be, we can't necessarily expect or anticipate. But the responsibility in that case is very clear. In case two, I'm just presenting kind of this contrast. What if instead of people intentionally being involved here with either a diversion of an asteroid or a redirection of an asteroid towards Earth, we have an asteroid coming towards the Earth and we could divert it, but then either through inaction or lack of preparedness, we don't do it. Then we have to ask ourselves who or what is responsible in this case. Obviously, we can say, oh, that's nature, it's an act of God, it's whatever you want to say. But if humans could have stopped that bad thing from happening, it seems like humans, humanity or one nation or one agency, whether it's a military or space agency within the expanse that is humanity here on Earth, maybe should have done something about it. And so this ethical issue, I think, is a really interesting one, because in the past, this was not anybody's responsibility, right? When an asteroid hit the dinosaurs, it wasn't the dinosaurs' fault that they got hit by an asteroid. That was just something that happened. But now that humans have these types of powerful technologies, we have space technology, we can transport things out there. We could either use an enormous atomic bomb, or we could use other more subtle ways of moving things around in space. We have to really ask this question: should we be preparing for these sorts of disasters? And if we don't, then is it just nature's fault, or is it really humanity's fault? All right, well, I'm reaching close to the conclusion now, and we've got lots of time for questions. So once again, this is just a review of the various sorts of risks or the various sorts of subjects that are in the book. And thank you very much. It's been wonderful. I'm going to stop sharing my screen, and then we can move on to questions and answers.
Thank you so much, Brian, for that wonderful overview of your book, Space Ethics, everyone, and bringing us into this kind of whole sort of unprecedented realm of thinking about ethics in terms of space. So I wanted to just say to everyone in the chat, so not in the Q&A, but in the chat, we've posted a link to a page on the Ethics Center website where you can find a link to information about Brian's book, including purchasing it, as well as more background, more information on space ethics. So please check out that link. I think you'll find it really fascinating. So Brian, we've got a bunch of questions, more coming in, which is great. I wanted to start with a couple and kind of pair them. Both have to do with concerns about the military and space, the militarization of space. So one is just, it was an important question. It's a little more technical, but I think it kind of creates a doorway into the second one. So the more technical question is, why has the technology not developed that well to stop ICBMs, like a missile to missile thing to stop ICBMs? There may be technology that we read about stopping, kind of missiles, but not ICBMs coming in. So what is the issue with that technology just not apparently working so well?
So there are some systems that are becoming more effective right now, is the first thing I would say. It's difficult to know a lot of the time in the testing, because the testing, of course, is always under controlled circumstances. So it's difficult to know how these things work in practice. We have seen examples of shorter range ballistic missiles actually being successfully intercepted. That happened recently in Yemen. Some of the military forces in Yemen fired a missile towards, I believe it was the United Arab Emirates or Saudi Arabia. I can't remember which one. And they actually managed to intercept it with a THAAD system, which is Theater High Altitude Air Defense. Now, that's not an intercontinental ballistic missile. The difficulty with intercontinental ballistic missiles is that they are moving at something close to orbital velocities. So once again, miles per second in terms of speed. One of the things that militaries are doing when they intercept satellites and destroy them is that they are demonstrating their capacity for also hitting ballistic missiles. Now, once again, ballistic missiles are still harder than satellites because satellites have a very clear orbit. They always follow it. You know exactly what they're doing. So it's easier to hit a satellite than it is to hit a ballistic missile. You have less time to figure out how to intercept a ballistic missile. So the problem is, why doesn't it work very well? It's just a really, really difficult problem. And it's something where you have to get it down to milliseconds or microseconds just to make sure that the interceptor and the target are in the same spot. The person who asked that question might also be recognizing, if they knew that I was on the island of Ebi, they might have known that Ebi is in Kwajalein Atoll. Kwajalein Atoll is actually where the United States does this interceptor testing. And so I've seen, when I was there about 20 years ago, I saw the interceptors launched and I saw ballistic missiles enter the atmosphere. Minuteman III, a couple of times I saw Minuteman III re-enter the atmosphere. And so this is one of the reasons that these sorts of issues are very, very kind of concrete, important issues to me, because I've seen what these things look like. And these, you know, the technology is difficult. It's also important, and it also alters the balance of power. So for a long time, there was an anti-ballistic missile treaty that said that we weren't allowed to have anti-ballistic missile defenses, or we were only allowed to have a limited number of them, because the logic of mutually assured destruction had to be preserved in that case, which is that if one side in the Cold War got anti-ballistic missile technology, then it would upset the balance of power and therefore destabilize the world, make it more likely to have a war. Anyway, there are lots of things going on there, but those are kind of the main issues.
Well, you know, Brian, thank you so much. I think that really helps us understand technically what's happening with these possibilities of intercepting. And I was thinking too, you know, sort of over the last years, going back decades, I think many of us may be familiar with ICBMs, at least the terminology and like the reality of missiles kind of hurtling through space in that way. But it's so striking in your presentation that questions about the militarization of space they include ICBMs, and they go way beyond that too. There's a lot of other stuff that's going on now. So a follow-up question from another guest on the Zoom call, who asked if you could care to ascribe any probability of success to the goal of keeping warfare out of space, including space-based attacks on Earth and space-based attacks on space in the long term?
Well, that is a really hard question. And I think the numbers change over time. So I don't think there's a very high probability of these problems happening in the next 10 years. But I mean, when I say not very high probability, I'm thinking about attacking other people's satellites, for example. This is a very probable thing that could happen. People in Russia, certain government officials have said that they see Starlink, for example. They see the Starlink system as a military weapon, and so even though it's owned privately by Elon Musk, they see it as a military resource to the United States, and therefore it's a target. And of course, Elon Musk said, "Oh, there's too many. You can't shoot them down." That's the wrong answer, actually, which is that Russia doesn't have to shoot down 1,000 Starlink satellites. It only has to start a debris cascade, which means it only has to hit the right ones at the right spot so that they start knocking into each other and splitting each other apart into more and more pieces. Right now, more than half of orbital near misses are Starlink satellites already. So I think maybe if I had to assign a probability for the next 10 years, I'd say maybe there's a 5 or 10% chance, which is a lot higher than I would like it to be. I'd like it to be closer to 0. And if we're thinking, you know, of course, longer term, then the probability goes up. But I would like to think that there's going to be a point in the future where everybody recognizes the futility of this recently, or it's going to be obvious that this is really a futile endeavor to try to have warfare in space. It's so difficult just to live in space in the first place that adding warfare and weapons on top of it just makes it so much worse. Life is very fragile here on Earth. It's extremely fragile in space. All you have to do is poke a hole in a spaceship and the people can be in big trouble if they can't patch it fast enough. And so I think the probability is not zero. I think I want to be optimistic and say that I think the possibility for space warfare, say in the next century, is still below 25% would be my hope.
We're going to go with that, Brian, as a hopeful sign. So let me follow up one more question here having to do with kind of militarization and some of the issues there, because another one came in that raised a question about the Outer Space Treaty you referred to. And I'm guessing maybe a lot of us aren't familiar, even that there is such a treaty. But the question is, the Outer Space Treaty is relatively unenforceable. If that's true, what is keeping nations from violating it?
Yeah, the Outer Space Treaty is an interesting one because it does rely a lot on people just saying that they're going to do it. It sets norms for behavior. However, like I was saying before, it's quite possible the Outer Space Treaty has already been violated. It could be that the Soviet Union, for example, put a nuclear weapon into a satellite up and it's just orbiting the Earth all the time and we wouldn't know about it. And if that nuclear weapon is up there, it doesn't actually have to be directed towards landing on anybody. If you set it off at the right altitude, then it'll cause an electromagnetic pulse over whatever region it explodes over, and that will cause extensive damage to electrical systems that are under that area. And it's a very widespread area. It could be thousands of miles across, depending on the altitude. So for all we know, it has not been violated yet. The Outer Space Treaty is not only about weapons, though. It's also about how we're going to do science in space. It's also about how we can expect to help each other if there's a crisis in space. It also talks a little bit about liability. If a piece of satellite lands on your country, who's responsible for that? So there are lots of other parts of the Outer Space Treaty that are not as controversial. Prime example being that if, for example, the astronauts on the International Space Station needed to be rescued, if you're a party to the Outer Space Treaty, then it would be expected that you should go and try to help them. And one of the nice things about that is that that's a good thing for international relations, right? If China can go and rescue American astronauts, that looks great for China, and it's also helpful to the United States, or vice versa. If Chinese astronauts need to be helped by America or other countries, that's great for everyone. And so that's in the Outer Space Treaty to think about helping each other in space, mutual assistance. The Outer Space Treaty does need to be updated. It is, let's see, it's over 50 years old. So a lot of things have happened in space in the last 50 years. It needs to think about things like Elon Musk's provocation. What if a Mars colony decides that it doesn't want to be associated with laws on Earth? It's going to be its own colony with its own laws. What's Earth going to do about that? And so these sorts of issues are being debated now. There are people who are thinking about these sorts of things in terms of space law and space policy and space ethics. And it's something that we do need to think about.
Brian, thank you so much. So wanted to shift gears a little bit into some more specific kind of ethics per se content. And this is a question from our friend and colleague, Patrick Lynn down at Cal Poly. Patrick was wondering your discussion about people ruin things. And he says, well, yes, ethics and values, they could be meaningless without humans, but humans don't need to be physically present at any particular location for ethics or value to exist. So the question is, do you think barren moons, planets, and other celestial bodies have intrinsic or other value that's worth protecting from an invasive species like humans?
So that's a great provocative question from Patrick. Thank you. Pat, for the question. And of course, those of you who are out there should know that Pat Lynn, of course, has been doing space ethics for a long time. So he's an old pro with these sorts of questions. I think the way I would approach actually this question of value in space, I think that there's kind of a scale of value, I guess is the way I would look at it, right? Which is that non-living things are kind of low on the scale of value. Living things are higher on the scale. We need to think about them more. And of course, intelligent species that are capable of suffering and virtue and vice and moral thinking are higher up there, just because we have the ability to think about ethics and make these sorts of ethical questions. When I think about the value of lifeless places in space, I actually think about it from a virtue ethics perspective, because it's very hard to answer the question of whether it has intrinsic value or not in a way that everyone will agree on. But we can agree that humans don't want to be vicious creatures. We want to be virtuous. We want to make the right choices. We want to have a good character. And so when we look at somewhere like the moon, we should think to ourselves, what would a bad person do to the moon? Well, a bad person, for example, might turn it into a very large advertisement, or would draw their face on the side of the moon that's facing the Earth, or other things like that that would be, anyone would say that's bad use of the moon. But think about something farther away. What about an asteroid and just gobbling up an asteroid that nobody knows about? And once again, you have to think, what would a good person do? Is that asteroid going to be used for good purposes? Is it going to help people? Is it going to alleviate suffering? Is it going to provide new habitat for creatures, maybe not just humans, but maybe, other Earth life forms also? And if there's nothing there, then it's a little bit difficult to say that we shouldn't do that. However, you can think of bad things to do to asteroids also. What would a bad person do with an asteroid? Redirect it towards the Earth, blow it up into little pieces so it creates a cloud of debris so that people can't move through it very easily. And I think this kind of wanton destruction is also a question too, which is that, there's a kind of ethics called environmental virtue ethics, where they say, what is unvirtuous or vicious environmental behavior? And we can all understand what those things are. Wanton destruction would be a prime example of that. And so what I would say is that wanton destruction in space, just going up there and wrecking things, is clearly vicious, bad behavior, and we shouldn't do it. But the questions become a lot more complex when we're talking about something like terraforming Mars. From the perspective of any Martian life form, humans terraforming Mars could be very, very bad. They've adapted to Mars the way it is right now. And it would, of course, be beneficial to humans and Earth life. People have also made the argument, actually, terraforming Mars will help Martian life, if there is any, because they'll get their ecosystem back. Mars used to be much more hospitable than it is now, but that was billions of years ago. And so once again, there's always these trade-offs and things to think about. And they're super difficult. So thank you for that question, Pat.
Brian, thank you so much. So maybe shifting a little here to other modes of engagement in space. So we were talking about militarization. You went through and what you just responded, a number of different examples. So this question has to do more with space travel, which I think is what's capturing many people's imagination, seeing Bezos taking off in a rocket, that kind of thing. So the question is, at what point is it necessary for a unified approach to space travel required for successful exploration? Can we get to the point of an Earth perspective versus an individual country perspective?
Yeah, that's a really interesting question. And I would bring that down to a very concrete example, which is that when Jeff Bezos was sending his tourists up into space, they were not wearing pressure suits. They were wearing just flight suits, jumpsuits. Very early on in missions to space, it was decided that if you're going into space, you need to wear a pressure suit, because if your module depressurizes, you die. And so astronauts have always worn pressure suits. Sometimes, they take their helmets off and things like that. But Jeff Bezos has decided that's not necessary for his flights. He's going to rely on the integrity of his vessel being strong enough so that you don't need the extra layer of protection. And so this issue of kind of standards and expectations for travel in space is a serious one, because we've already seen that private organization has a different understanding of safety in space than a lot of space agencies have decided on in the past. And of course, when we think about taking that to the next level, going into the future, I think that a lot of the ways humans learn things, unfortunately, is by having a bad thing happen. And so we might discover that there will be a lack of standardization or a lack of understanding of expectations in space that will lead to misunderstandings or accidents or other sorts of problems. And that's something that we should be thinking about now. We should be thinking about, how do we standardize? How can we make sure that different vessels in space are capable of linking to each other, for example? Is there some way that we can make sure that those things work out? Or expectations about, we're not going to bring an asteroid close to the Earth for mining purposes. Maybe we won't put it in orbit around the Earth. Maybe we'll put it in orbit around the moon or something like that. So these sorts of standards and expectations and policies are things that absolutely need to be worked on. And like I said, there are people working on them, but ultimately it becomes a political question, which is so much more complicated.
So Brian, building on that, on what your response is there, kind of leads into another question, which has to do with all these different options you're talking about. Like, how do we start prioritizing them? Even if it is, as you say, it's ultimately going to be a political question. People, somehow political bodies are going to have to decide this. But this question puts it in the language of opportunity costs. Given opportunity costs, what should be our highest priority? For instance, should low probability existential risk, like asteroid defense or planetary protection, take precedence over higher probability goods like scientific research?
Yeah, so that's another great question. I think if I had to start prioritizing issues in space, I think space debris is definitely one of the first ones that comes to mind, because if space debris gets out of control, we start losing access to space. We start, our satellites start getting messed up, and ultimately we can't get out into space anymore under the worst case scenario. Militarization of space is certainly a huge one. It's becoming more and more of a problem, and it needs to be talked about in more detail, and ultimately international treaties and some sort of inspection and enforcement regimes need to be set up on those sorts of issues. The existential risk questions are real. I wouldn't necessarily think of it in terms of extinction risk. So for example, Elon Musk worries about humans going extinct on Earth. That's pretty difficult to drive everyone extinct, just because there are people all over the place, right? What is easier is to cause some other type of horrible disaster, with large percentages of the Earth population being destroyed in a nuclear war or something like that. And those are, I think, real worries that we should be considering, because if a very big disaster like that happens too, we also could potentially be cut off from space, and it's a very bad thing for human civilization. And of course, we don't know how bad something like that could be, whether it has to do with weapons that are artificial intelligence or nuclear war or engineered pathogens, things like that. So I would say that those lower probability, higher harm things are very risky. There are very high probability things that are also very high harm that are happening right now in terms of space debris. And so you absolutely do need to prioritize to a certain extent. And we need to start getting into our heads that these are serious issues that if we don't deal with now, we're going to have to deal with them in a worse form later on.
Thank you so much, Brian. And maybe as this question builds on kind of our sense of all these different options in space. So what about the notions of kind of human habitability up there in some way? And this question builds on something in your book, which notes in chapter 12 in your book, you address living in totally human constructed environments, but mainly in the context of very long duration, even multi-generational space travel. So this questioner is interested in the nearer term issues of living in artificial habitats in cislunar space, such as the classic O'Neill settlements at the Earth-Moon L4 or L5 regions. Mm-hmm. Could you speak more about ethical issues of artificial human space settlements in space versus those on natural bodies like Moon, Mars, etc.?
So this is a really interesting issue. What I would say is, first of all, just to explain some of the words that were used there. The idea of an O'Neill colony is just, put a colony up in space, and there are different various forms of it. You can make a donut shaped one, you can make a cylinder shaped one, you can make a sphere. And these are, once again, completely artificial environments that are created by humans in space. And we already have that in the form of the International Space Station and previous space stations that we've seen in the Chinese space station, other space stations that are up there. We have experience living in these sorts of places. We also know that it's very difficult to maintain those environments. And of course, if they're whether the settlement is on the Moon or on the surface of Mars, there's still those problems. Mold, for example, other sorts of microbes end up growing behind the panels in the space station. And then all of a sudden everybody's, sniffling because they're breathing too many mold spores. So these sorts of problems are real. One of the reasons in the book that I talk more about settlements on the surfaces of objects is because when you're on the surface of an object, you have natural resources that are easily accessible. You don't have to transport the resources to your location, your settlement in space. However, these kind of free-floating settlements are likely to be built possibly sooner than, even a settlement on Mars potentially. And, and I'm talking about beyond just the International Space Station, since we already have it. And once again, they're not going to be self-sustaining. They're going to be always reliant on having imported, resources for them to use. And so that's really the reason I concentrate more on things that are on an object, because it's just a better resource environment, whether it's an asteroid or the Moon or Mars. But absolutely, these free-floating settlements are a possibility also.
Brian, we just have a couple of more moments here. So let me give you one quick question, which is obviously immensely complex, but if you could answer it briefly, and then I'll close with one final question from the audience. Are we going to find life in space?
I think the probabilities are high. The question is, where are we going to find it and when, I guess, would be my response. And of course, there is the possibility that we might not find much out there. I think, once again, I think the possibility is pretty high. The probability is high. Is there going to be some hiding under the ice of Europa or a microbe on Mars? Those are probabilities that we're going to explore. We're going to find out about those things, in the next coming decades. And of course, even with telescopes, we might be able to see the atmosphere on other planets out there, and other star systems might have oxygen atmospheres, which would indicate life being there. All right, quick answer. I want to hear the last question.
The last question is from the audience. Is the best example of terraforming on Earth Las Vegas, for better or for worse?
Las Vegas, that's a good question. I can think of some other places on Earth that are also, amazing cities out there in the desert. A lot of these things, for example, in Saudi Arabia and the Middle East, they've done a lot of this sort of thing too. But I think these are great questions, and I really appreciate it. Thank you so much. David, thank you so much for hosting today, and this has just been wonderful. Thank you.
Well, Dr. Brian Patrick Green, we so highly value Brian as our colleague at the Ethics Center and at Santa Clara University. Encourage all of you to please buy Brian's book, which is available. If you go to that link in the chat, not the Q&A, but in the chat, you can find link to Brian's book and more information about his work and other work on space ethics. Thank you all so much for joining us today. So many great questions. I'm so sorry we couldn't get to them all, but we deeply appreciate your engagement with us. Please contact us about space ethics and other matters in applied ethics. I'm David DeCoste from the Markkula Center for Applied Ethics. Thank you so much for being with us today.